In this section, we will work on few problems based on finding the sum of the given geometric progression. So let's begin. Problem number 1. So here we have a geometric progression. We need to find the sum to 8 terms. So let's begin. First, here we have the first term, which is given by 0.15. Then we have the common ratio. To find out the common ratio, we take the second term, which is 0.015, and divide it by the first term, that's 0.15. So this is going to give us 1 over 10. Now here 1 over 10 means this value is less than 1. So that means we will have to use the formula for finding the sum of the n terms. That is a times 1 minus r raised to the power of n divided by 1 minus r. Fine. Now the sum up to the 8 terms. The sum up to the 8 terms will be equals to the first term, which is 0.15. This will get multiplied to 1 minus r. So r is 0.1 raised to the power of 8 divided by 1 minus 1 over 10. So that's 0.1, which will be equals to 0.15. So 1 minus 0.1 will be 0.9 multiplied to 1 minus. So this is going to be equals to, let's keep it as 0.1 raised to the power of 8. Now we will simplify 0.15 divided by 0.9. We'll multiply both numerator and the denominator with 100. We'll get 15 divided by 90. We know that 15 times 6 is 90, but this simplifies to 1 over 6 times 1 minus 0.1 raised to the power of 8. So this is going to be the sum to 8 terms of the given geometric progression. Now let's move on to the second problem. So here we have our first term given by square root of 2. The common ratio will be the second term, which is 1 over square root of 2 divided by the first term, which is square root of 2. So we have 1 over square root of 2 times 1 over square root of 2. This gives us the value 1 over 2. So this is going to be our common ratio. Now we need to find out the sum to the 8 terms. So this will be equals to the first term, a, multiplied to 1 minus r. So r value is 0.5 raised to the power of 8 divided by 1 minus half. That is 0.4. So this is going to give us square root of 2 divided by 0.5 multiplied to 1 minus 0.5 raised to the power of 8. Or in simple terms, this will be 2 times square root of 2 multiplied to 1 minus 0.5 whole raised to the power of 8. So this is going to be the sum to the 8 terms of the given geometric progression. Let's move on to the third problem. So here this is a geometric progression with the first term a 2 over 9. Then the common ratio r will be equals to, we'll take this second term, which is negative 1 over 3, and divide it by the first term. So that's simply multiplying it to 9 over 2, the reciprocal of the first term. So 3 times 3 is 9. So that means we have negative 3 over 2. This is going to be a common ratio. And our n value is equals to 5. So we'll find out the sum to the fifth term. So clearly here our value is less than 1. So that means we will use the formula, our first term, 2 over 9 multiplied to 1 minus the common ratio, which is negative 3 over 2 whole raised to the power of 5 divided by 1 minus negative 3 over 2. So this is going to give us a value 2 divided by 9. Now we have 1 minus, so let's find out the value of negative 3 over 2 whole raised to the power of 5. So this gives us negative 1 raised to the power of 5 times 3 raised to the power of 5 divided by 2 raised to the power of 5. So negative 1 raised to the power of 5, so that's negative 3 raised to the power of 5 will be 243 divided by 2 raised to the power of 5, so that's 32. So we have negative of negative 243, so this will become positive. So we have positive of 243 divided by 32 whole divided by, so in the denominator we have 1 plus 3 over 2, so that's 5 over 2. So 2 over 9 divided by 5 over 2, so that's 4 divided by 45. And this is multiplied to the numerator part, so we have 243 added to 32, so that's, so we have 275 divided by 32. Now 4 times 8 is 32. Then we have 5 times 9 is 45. 5 times 5, 25. So 55 times 5 is 275. So this is going to give us the final value. 55 divided by 9 times 8 is 72. So our value, the sum up to the 5 terms will be 55 over 72. So let's move on to the fourth problem. Problem number 4. So here we want to obtain the sum of the given geometric progression up to n terms. So let's begin by rewriting sum as, so we have Sn, this will be the sum of the n terms. So we'll take the first term, which is x plus y, add it to the second term, so that's x squared plus xy plus y squared. That will get added to the third term, which is x cubed plus x squared y plus xy squared plus y cubed, and so on, and goes all the way up to the n terms. Now what we're going to do here, we're going to divide and multiply with x minus y. So 1 over x minus y, we're going to multiply each term with x minus y. In doing so, we have x minus y times x plus y. This is going to be our first term. The second term will then become x minus y multiplied to x squared plus xy plus y squared, plus the third term will then become x minus y multiplied to x cubed plus x squared y plus xy squared plus y cubed, and this goes all the way up to the nth term, or the n number of terms. Now when doing so, since we're multiplying with x minus y, so our first term, which is x minus y times x plus y, this product is actually x squared minus y squared. Then coming to the second term, x minus y times x squared plus xy plus y squared, so this is actually x raised to the power of 3 minus y raised to the power of 3. Similarly, the fourth term will then become x raised to the power of 4 minus y raised to the power of 4, and this goes on up to n number of terms. So now that we have in a simplified form, what we can do, we can write all the terms containing the functions of x. We have x squared plus x cubed plus x raised to the power of 4. This sum goes all the way up to n number of terms. And then we have negative, we'll take negative as the common factor, all the y components. So that means y squared plus y cubed plus y raised to the power of 4, going all the way up to n number of terms. Fine. So let's find out the sum. Here, this is our Sn, sum of the nth term, 1 over x minus y. Here, this is a geometric progression with the first term being x and the common ratio r equals to x cubed divided by x squared, so that's x. So that means our sum will be the first term multiplied to the common ratio x raised to the power of n minus 1 divided by x minus 1. Minus, we'll consider this is also a geometric progression with the first term being y and the common ratio r being y. The first term is, this is x squared, actually my mistake, so this is x squared, and the first term here is y squared with the common ratio r equals to y. So we'll have y squared multiplied to y raised to the power of n minus 1 divided by y minus 1. So this is going to be the sum up to the nth term of the given geometric progression. Let's move on to the next problem. We need to find the sum up to 2n terms of the given geometric progression. That means we need to find 3 over 5 added to 4 over 5 squared plus 3 over 5 cubed plus 4 divided by 5 raised to the power of 4. This sums up to 2n terms. Now what we'll do, we are going to use a trick here. So we're going to take the first term, 3 over 5. Then we'll consider the third term. Then we'll consider the fifth term. This goes all the way up to n number of terms. Then this was going to be one sum. Plus we'll have another n number of terms. Here the n number of terms will comprise of the first term 4 over 5 squared. Second term 4 divided by 5 raised to the power of 4 plus n terms. Then doing so, we obtain two geometric progression. So in this first geometric progression, the first term is 3 divided by 5 with a common ratio r equals to 1 over 5 squared or 25. And in the second geometric progression, the first term is going to be 4 divided by 25 and the common ratio is going to be 1 over 25. Now we can use the sum formula to find out the total sum. So we have 3 divided by 5 multiplied to 1 minus, we have 25 raised to the power of n divided by 1 minus 1 over 25. So this is the first sum. The sum of the second GP is going to be 4 over 25, the first term, multiplied to 1 minus 1 over 25 raised to the power of n divided by 1 minus 1 over 25. Right. So let's simplify that. So here in the we have 3 over 5 divided by 24 over 25 multiplied to 1 minus 1 over 25 raised to the power of n, plus we have 4 over 25 divided by 24 divided by 25 multiplied to 1 minus 1 over 25 raised to the power of n. Fine. So let's further simplify. We're going to get 3 times 8 is 24 and 5 times 5 is 25. So we're going to get 5 divided by 8 multiplied to 1 minus 25 raised to the power of n, plus here we have 25 and 25 cancel out, and 4 times 6 is 24. So we have 1 over 6 multiplied to 1 minus 1 over 25 raised to the power of n. So we have 5 over 8 plus 1 over 6. This will get multiplied to 1 minus 1 over 25 raised to the power of n. So 5 over 8 plus 1 over 6, that sums up to 19 over 24. So our final value is 19 over 24 multiplied to 1 minus 1 over 25 raised to the power of n. So this is going to be the sum to n terms of the given geometric progression. Let's move on to the next problem. So we need to find the sum to n terms of the given geometric progression. So let's begin. Our first term will be given by, so let's consider the first term as a in uppercase. So that's a divided by 1 plus iota. Then the common ratio will be, we'll consider the second term, which is a divided by 1 plus iota whole square, and divided by the first term, or simply multiplying it to the reciprocal of the first term. So that's 1 plus iota divided by a. A and a gets cancelled. 1 plus iota gets cancelled from the numerator and the denominator, leaving us with 1 over 1 plus iota. So this is going to be the common ratio. If we want, we can also convert this back to a complex number. That means write it in the standard form, a plus ib. All we have to do is multiply the numerator and the denominator with the complex conjugate of the denominator. That's 1 minus iota, which is going to give us 1 minus iota divided by, so 1 plus iota times 1 minus iota, that will be equals to 2. So this means we have half minus iota times half. So let's find out the sum. So the sum up to n terms is going to be the first term. So our first term is a divided by 1 plus iota multiplied to, so we'll take half minus iota times half whole raised to the power of n minus 1 divided by the common ratio, divided by common ratio minus 1, which is half minus iota times half minus 1. That means we're going to have, let's further simplify this, we have a over 1 plus iota multiplied to half minus iota times half raised to the power of n minus 1 divided by, so half minus 1 will be negative half, the negative half minus iota times positive half. Let's simplify a divided by 1 plus iota whole divided by, so we have negative half minus iota times negative half. So if we take negative half as the common factor, so we have 1 plus iota. So this will be equals to, so we'll take negative half to the numerator. So this is going to give us negative 2a divided by 1 plus iota whole square. So 1 plus iota whole square, so that's negative 2a divided by, so we're going to get 2 iota. So 2 and 2 gets cancelled, and we have negative a divided by iota. We know that iota squared, that value, that's negative 1. So in place of negative a, we can replace it with negative positive iota squared times a divided by iota, or simply a times iota. So that means our final sum, that's going to be equals to a times iota whole multiplied to half minus iota times half whole raised to the power of n minus 1. So this is going to be the sum to the n terms. So let's move on to the next and the final problem. So we need to find the sum of the given. So that means we need to find the sum of 2 plus 6 plus 18 all the way up to the last term, which is 4374. Now we will first find out the value of the number of terms that's present here. We know that an, the nth term of a GP, since it's a geometric progression with the first term being 2 and common ratio being 3, so our nth term will be simply a times r raised to the power of n minus 1. Now, nth term, which is the last term, that has a value of 4374. This is equals to the first term, which is 2 multiplied to the common ratio 3 raised to the power of n minus 1. So 4374 divided by 2, that will be 2187 equals to 3 raised to the power of n minus 1. Now 2187, that's 3 raised to the power of 7. This will be equals to 3 raised to the power of n minus 1. So since the base are equal, that means we can equate the power. So n minus 1 will be equals to n, solving for 7. So solving for n, we will get 8. Now that we have the total number of terms, that's 8. So sum up to the 8th term, that will be equals to the first term multiplied to the common ratio of 3 raised to the power of 8 minus 1 divided by 3 minus 1. So here 2 and 3 minus 1 will get cancelled. So we have 3 raised to the power of 8 minus 1. So let's find out this value. 3 raised to the power of 8. So that's 6561 minus 1. So our final sum will be 6560.